Assalamualaikum, Rabbi Shari Sadri, Vayasili Amri Walu Lugdata Milisani Kokoli, Rabbi Zidilma. Okay, today we are going to talk about the another topic of this chapter number 2.1, that is network topologies. First thing that you need to know is what is a topology? The way you connect the computers forms a topology. And then there are basically four types of topology that you need to talk about. The first one is bus network, star network, mesh network, and hybrid network. About the bus topology or bus network topology, what is the main feature? You can see it is using a single central cable to which all the connected computers are going to share the data and the resources. It is easy to expand and requires now. Let's talk about the advantages. First thing is the main construction. It is a single central cable to which all the computers and devices are connected. Then another thing about it, there is an advantage that it is easy to expand and requires less cabling. Data can travel in only one direction if data is being sent between devices rather than other devices cannot transmit. Now, another thing about the construction of this bus network is the use of the terminators, and these terminators are present at the end to prevent signal reflection or signals bouncing back. So the terminators weren't placed. You can see the terminators. These are the terminators. The black ones are the terminators. So that if the terminators were not placed, then the signals will keep on bouncing back and forth. So these are the main features that you need to know about bus network. And another thing is bus networks are typically peer-to-peer. Now, these are the few things that we need to know about the bus topology or bus network topology or bus network. Typically peer-to-peer. Like here, all the connected computers are of the same level. Easy to expand and requires less cabling. This is again the advantage. Moving to the disadvantages. If the main cable fails, then it means if the main cable fails, the whole network comes to a standstill. Means it is not going to be able to send or receive the data. Performance of the network deteriorates under heavy load. I mean, it cannot handle large amount of data traffic, so that is also a problem. The network is not secure since each packet passes through every node. Although definitely not every node will be taking, I mean, this is what we already know, that in communication, a very important thing is the data will only be taken by the computer to which it is to be sent. All others, even if they receive, they will not be receiving it. They will be sending it to the other nodes because it is not meant for them. So that is again, you can say a sort of a disadvantage for this also that we need to be aware of. Okay, these are the disadvantages um, of your bus topology. Advantages I mentioned again. Even if not one node fails, the network continues to function. Easy to increase the size of the network by adding additional nodes. So the same thing as highlighted here is mentioned under the heading of advantages also. But if you are asked to draw a diagram, you can draw this diagram just by drawing a line with terminators. Do not forget to place the terminators, and you can simply draw a computer like this. You can simply draw a box also, and that will definitely give you some marks for writing properly or drawing properly the bus network. So this is how the questions can come in the paper. Asking about the features, asking about the advantages and disadvantages, asking you to draw the diagram to explain that how bus topology works. In bus network topology, each node looks at each packet and determines whether or not the address of the recipient in the package matches the node address. If so, the node accepts the packet, otherwise it is ignored. The same thing as I talked about. These are more suitable for situations with a small number of devices with light traffic occurring. For example, a small company or an office environment. So this is what is important for you to know. When should we go for what? This topology is feasible when there is not much traffic, there's less number of computers connected, then we go for bus topology. Secondly, star topology or star network uses a central hub or switch, and each computer or device is connected to the hub or the switch. So there's central management, and that is the most important feature of the star topology. Data is going to uses a central hub switch, and each computer or device is connected to the hub or the switch. Data going from host is directed through the hub or the switch. Now, if you talk about, like, for example, if the data is supposed to be sent from 1 to 3, so it will be sent to the hub first, and the hub will decide that where is 3 present and will be directed to the node 3 in case of the use of a switch. So we'll talk about that also. And initial cost. Now, what are the disadvantages or the advantages? Talking about the advantages first. The advantages are, okay, now let's talk about the advantages. Advantages are And this disadvantages. Uh, Disadvantages of a star network include costs are high, as you can see the diagram. Every single computer is connected to the switch, and the switch is going to direct the data to the destination. So definitely this is going to be expensive because of the use of a lot of cabling. If the central hub or switch fails, then the whole network comes to a standstill. So these are the two disadvantages, and coming to the advantages, there are many. Data collisions are greatly reduced because of this topology, star topology. More secure networks and security methods can be applied to the central node. Easy to improve by simply installing an upgraded hub. If one of the connections is broken, it only affects one of the nodes. So if this, for example, if this connection has developed some faults, so this is the only computer which is affected. All other computers will still continue to function, but in case the hub or the switch has developed some faults, then definitely the whole network comes to a standstill. That is a disadvantage that is mentioned here. Now, how the questions can come again the same way? You are asked to draw the diagram, you are asked to, maybe sometimes the diagram is drawn for you, and you are asked to write the advantages and disadvantages. So this is how you can answer in your question. How packets are handled depends on whether now this is what we'll talk about right now also. This is what I said, a hub or a switch, difference. If the use is of a hub, then it will be the data or sent from one computer will be sent to all the connected computers, and definitely only the computer to which it is meant will take the data, and others will ignore. But in case of switch, it will only send the data to the destination. It will not be sent to other network computers. For example, if I'm talking about an example, if I have to send the data from this one to this one, like this is the sender and this is the receiver. So if it was a hub, it will be sent to all the computers. But if it was a switch, it will be only sent from 1 to 3. There will be no other computer that will be involved because the switch will be directing to the designated computer. And this is what you need to know about the differences. And this is coming next also in one of the topics that is covered next. So I've explained it to you here. I think that is not going to be a problem because this is what is the explanation here. The hub or the switch difference is hub is going to broadcast or send to all the connected computers, and switch is going to send to the designated computer only, not to all the connected computers. Next one, the third topology is the mesh network or mesh network topology. And what is it? It is based on routing and flooding. And what is routing? As the name implies, routing means using the routing table, it will be working like a router and will be directing to the destination by using the shortest path, shortest route, as the router is doing. So mesh is going to be finding out the shortest path, the shortest route, and will be directing the data through the shortest route to the destination. While in flooding, as the name implies, a flood where the data will be sent in the form of a flood. So it will be sent via all the nodes and uses new routing logic. And this makes it not an intelligent choice, because routing is definitely an intelligent choice because you are going to send the data to the required, so the shortest path you are going to reach the destination. And you can see here, there's no routing logic being involved, which can lead to unnecessary load on the network. And that is a type of the peer-to-peer network. You can see here, this is also an example of a peer-to-peer because you can see the number of connected computers or the kind of network. As you can see, if I showed you the diagram, isn't it similar to the peer-to-peer topology that we have talked about? Every single computer is connected to the other ones. So this is why they have mentioned this. It's a type of peer-to-peer network, but it's fundamentally different. Disadvantages. Disadvantages of a mesh network and the advantages of a mesh network. So as the name itself is telling you, a lot of cabling is involved, which is expensive and time consuming. Setup and maintenance is difficult and complex because you need to connect each computer with each other, and that is difficult and complex. Advantages include easy to identify where the faults are. Any broken links in the network do not affect the other nodes. Good privacy and security. The network is relatively easy to expand. You can add on more computers easily as compared to any other topology. Examples, applications where the mesh topology is being used, internet and WANs or MANs are typical examples of mesh network. Examples include industrial monitoring and controlling applications. As you can see, the example of medical monitoring of patients in a hospital, electronics interconnectivity, Similarly, modern vehicles are also using wireless mesh network topology to enable the monitoring and controlling of many of the components. So this is just a very brief discussion about the mesh topology. And last is my hybrid. Just remember, one term hybrid means always a combination. So here we can see whenever we are mixing two or more different topologies, then that forms a hybrid topology. As you can see here, we are connecting bus and star, or maybe bus and mesh, and so on. This is the diagram to make you understand that what is it looks like and what are the advantages and disadvantages. So this is how the hybrid network looks like. You can see here, this is the main cable indicating it is bus. And then you have maybe a star topology is used here, and that is bus star. Bus and star, both topology is being used. That is going to make it a hybrid network. Now, what are the advantages? Advantages and disadvantages depend on which types of networks are used to make up the hybrid network. So there's no one particular advantage or disadvantage. It is dependent on which type of network topology is being used to form the hybrid network. An additional disadvantage is that they can be very complex to install, configure, and maintain. That is a disadvantage. In order to install it, in order to maintain it, in order to configure it, that is needing specialized supervision, and that is going to be an expensive task and definitely tedious also. Advantages include they can handle large volumes of traffic. It is easy to identify where a network fault has occurred, well suited to the creation of larger networks. So whenever you need to create a very big network, then in that case, a hybrid network is the best choice. Note that handling the packets in hybrid network will depend on which of the above topologies is being used. Again, a repetition that which topology is going to be used in order to create this hybrid network is going to decide the advantages and the disadvantages, is going to decide that how the data is transmitted from one node to another, and that is the main thing that you need to know about the hybrid topologies. Another important topic of this chapter is public and private cloud computing. And for that, the very first thing that you need to know is what is cloud computing. So cloud storage is a method of data storage where data is stored on offsite servers or remote servers. The physical storage covers hundreds of servers in many locations. And the same data is stored on more than one server in case of maintenance or repair. And that means, although it is data redundancy, but that is advantageous because in case of some problem, then still you will be able to recover the data because it is stored on the backup servers. The types of cloud storage can be public cloud, means the storage environment is the customer client and the cloud storage providers are different companies. Private cloud, which is owned by a certain company, like normally the companies are creating their own private clouds, which is accessible from within the environment only, not from outside. And then hybrid, again, the word hybrid use a combination of public and private, where some features are going to be used from private and while some features are going to be from public. And you can see here the customer, client, and cloud server providers are different. Is going to be your public cloud. And private is going to be provided by a dedicated environment behind a company firewall. So this is what you need to know about the definitions of the cloud computing. What is it and how do we work on it? And then we need to know about the pros and cons, advantages and disadvantages of cloud. And just very quick recapping, although we know it, but still very quick recapping, what we need to know is customer client files stored on the cloud can be accessed at any time from any device anywhere in the world, provided internet access is available. So this is a very big advantage that you can access it from anywhere, anytime, just the use of the internet. No need for a customer client to carry on an external storage device with them. Like I don't have to carry my storage medium with me anywhere at all. Provides the user with remote backup of data to aid data loss and disaster recovery. In case of some problem occurring, I don't have to worry at all because the management of data, but the backing of the data is the responsibility of the cloud storage companies. Recovers data if a customer client has a hard disk or backup device failure, offers almost unlimited storage capacity. So if I have stored the data on cloud, then it will be advantageous. Just giving an example, Google Drive is cloud. You can talk about iCloud, that is cloud. Apart from pros, there are a few cons also. If the customer client has a slow internet connection or unstable internet connection, then the cloud data can never be accessed. It will be taking longer, definitely. Costs can be high if large storage capacity is required, expensive to pay for high download, upload data transfer limits, and definitely the potential failure of the cloud storage company is definitely going to be there, posing a risk for your data. Even your backup data can also be lost in case of some problem. Then there are a few examples that are mentioned here for you to go through, that there were some instances when the cloud storage can say there was some cloud storage problems, but that is only for the purpose of reading. You don't have to prepare it for your papers. And then repetition of some stuff. Now I'm moving to another important topic, and that is wired and wireless. What is wired and what is wireless? Wired means using cables, and wireless means Wi-Fi and Bluetooth. I mean, these two terms we know very often, like we use them quite often. So just very quick, Wi-Fi wireless fidelity is something that is basically offering you the service through which you can access the data over a large area. And talking about the Bluetooth, Bluetooth is a limited one, a limited area where you can see is going to be used when transferring data between two or more devices which are less than 30 meters apart. The speed of data transmission is not my main requirement, and using low bandwidth applications are going to be my choice. So this is why we use Bluetooth. That is the example of your that you can see if you are sending music files from a mobile phone to a headset, then you will go with Bluetooth. Wi-Fi is a bigger one, as we see, and here this is again a diagram to make you understand the working of a Wi-Fi, but not from the examination point of view, at least right now. You need to concentrate on just what Wi-Fi and Bluetooth are for, and they are meant for the connectivity over a larger area and wireless basically. Now, here is a comparison between the three infrared, microwave, and radio waves. You can see the bandwidth is going to be the highest for infrared and it will be lowest for the radio waves. Infrared, microwaves, radio waves. Then penetration means how much data can be entering or not entering. Radio waves has the highest penetration, then microwaves, and then infrared. And attenuation means loss of signal strength as the distance increases. So that is again, you can see radio waves have the best attenuation, like they are going to be suffering from this problem. Now, penetration measures the ability of the electromagnetic radiation to pass through different media. Like, for example, you can see this is the definition. If it comes in the paper, or you need to know that what is the term meaning, ability of electromagnetic radiation to pass through different media. That is your penetration. And attenuation, as I said, loss of signal strength as distance increases. That is attenuation. Or you can say another definition is here, reduction in amplitude of a signal. That is also the same, that you can go for, like maybe due to any reason, maybe due to walls or maybe due to the rain. So there will be some problem in the signal strength, and that is going to be uh, definitely handled through different means. Another one is your satellite communication. Why we need satellite? What is the purpose of satellite communication? So very quick talking about this one, we have this is the Earth, and this Earth has a number of ground stations, and along with that, you can see that there's a satellite also. So this satellite has a connection with the ground station that are present on the Earth, and they are going to relay or transmit the signals to another position, and through that the communication is going to take place. Although we are positioned in different parts of the world, or maybe we are all able to connect because of this use of the satellite. So just a small discussion of satellite is discussed here, and then later it will be discussed in a later part of the chapter also. Now, another important thing is wired. And for that, you need to know about the three types of wired communication, or the cables. The first one is your twisted pair cable. The second one is your copper cable. And lastly, it is the fiber optic cable. So what is twisted pair? Most common type of cable used in landscape. Now, before I proceed to this one, let me highlight the key points. Most common cable type used in lands. Now, they are now talking about the limitations, or you can say the disadvantages. Lowest data transfer rate, suffers the most from external interference, such as electromagnetic radiation. However, it is the cheapest option. Now, still, what is it used for? Why is it still useful? Because it is the cheapest option. So let me highlight the keywords here so you can underline, and in your books also can make a note for yourself also. Basically, lowest data transfer rate is a disadvantage, suffers from external interference is also a disadvantage, but cheapest option is an advantage. Two types of twisted pair cable. The first one is shielded and second one is the unshielded one. UTP and STP. Unshielded twisted pair and shielded twisted pair. As the name implies, shielded means it is going to have a covering over it, and this is the cable that is going to protect it a little bit from external interference. Although it will not be eliminated completely, but because of the use of shielding, it will be a little beneficial, and unshielded is used by the residential users. And where do you find it? If you just look at the diagram, maybe you have seen that this is the cable that we use in our telephone lines. Like the telephone cable is basically the twisted pair cable, and this is why they have mentioned unshielded is used by the residential users in the form of your telephone cables. Shielded is used commercially because the cable is going to be under some protection, and that will make it a better choice to be used for for the commercial users. The second one is coaxial cable. And what is it? It's most commonly used cables in MANs, metropolitan area networks, and by cable television companies. So if you really want to see, you can see this cable with your television sets. And this is the one which is getting the signal from your cable providers. The cost is now, let me highlight the points. The cost is higher than, you can see the cost is higher than twisted pair cable, and they offer a better transfer rate. Now, cost is higher than twisted pair cable, but they offer a better transfer rate and are affected less by the external interference. Again, let me highlight the key points. Now, cost is higher than twisted pair cable, but better data transfer rate and are less affected by the external interference. Coaxial also have about 80 times the transmission capacity of the twisted pair cables. Coaxial suffers from the greatest signal attenuation but offers the best anti-jamming capabilities. So just let me highlight the key points, because if the question comes in the paper to define the different types of cables, at least you have the key points here for your reference. Most commonly used in MANs and by cable television companies, cost is higher than TP, twisted pair cable, offering a better transfer rate and are affected less by external interference. They suffer from greatest signal attenuation, but they are offering the best anti-jamming facilities. Now, last but not the least is my fiber optic. And this is commonly used to send data over long distances because of now, these are all the advantages, as you can see. Fiber optic cables are most commonly used to send data over long distances because they offer the best transfer rate. The main drawback is the high cost. So basically, the fiber optics are using pulses of light rather than the pulses of electricity to transmit the data, and they have about 26,000 times the transmission capacity of the TP cable. So just let me highlight all the key things that you need to know about the twisted pair cable. The only problem is the cost. Otherwise, that is composed of all, like that is what we see in our network cable is basically the main network cable is my fiber optic cable. Now, another very important thing is wired versus wireless. What should we go for? Wireless is easy to expand. Devices have increased mobility. Devices less secure than with wired systems. Data transmission rate is slower. Signals can be stopped by thick walls. And now again, let me highlight. Okay, now just I've highlighted all these points, and Azan is going on, so just give me 2 minutes, and then when Azan finishes, and I'll talk about these points, because again a question has come in the paper dealing with the advantages and disadvantages of the wired or wireless communication. And just give me 2 minutes, let Azan finish, and then I'll continue. Okay, wireless network, easy to expand network, devices have increased mobility. These are the two advantages of wireless technology. As you can see, you buy a new telephone set, you can connect wirelessly faster. There's no involvement of anything. But increased chances of interference from external sources, less security of the data transmission is slower. Remember, wireless is slower and signals can be stopped by thick walls. So these are the yellow ones are talking about the advantages of wireless communication, and the pink ones are denoting the disadvantages or the limitations. Moving to wired network, more reliable and stable network connection, data transfer rate is faster, no dead spots, and last but not the least is the cheaper. Installing the wired network is going to be a cheaper option as compared to the wireless one. And talking in general about not us, but the companies basically. And when it comes to wired networking, the disadvantages are devices are not mobile. We have to be at that position. Lots of wires can lead to tripping hazards, overheating of connections, and disconnection of cables during routine office cleaning. So these are a few disadvantages and advantages of wired and wireless. You need to prepare this topic also for your paper, and then you'll be through. Moving to to another topic, hardware requirements of networks. And here we can see hubs, and here the diagram, the same as I talked about. Hubs are sending the data to all the computers connected. As you can see, packets are sent to the hub, and they are going to be sent to all the network computers in all together. That is a limitation as I talked about earlier. But when you talk about the switches, here we can see the diagram itself is telling you the switch is getting the packets. It will be sent only to the designated computer. The same thing as we talked about with respect to the star network. So the same thing is explained with the help of a diagram to make you understand a little better. The hub is sending to all, and sub is only sending to the designated one, because it will be composed of the because it has the MAC addresses. So this is something let me just talk about. Each device in a computer on a network has a MAC address that is a unique one, and that is identifying the device. The data packets sent to switches will have a MAC address identifying the source of the data, and additional addresses identifying which device is going to be receiving the data. So this is important. How the data is sent accurately to the computer is only happening because the device's MAC address is a part, and because of this, the switch is able to know that to which device the data will be sent, and that is why it will be able to work a little better, faster, more secure as compared to the other one. Another device of importance is repeater, and this is simply meant to boost the signals. We can see here when signals are sent over long distances, they definitely are going to suffer from some sort of attenuation or maybe signal loss. So repeaters are simply added into the network to make the system work a little better. Repeaters are devices which are added to transmission systems to boost the signals. Now let me highlight again. So it can travel greater distances. And they are there to amplify the signals on both analog and digital communication links. So just be clear, the repeaters are there to boost the signals. Just like, for example, just giving an example that there are different devices which are connected to boost the signal. So they are simply the signal boosters. And they are not intelligent. They are not going to be, just remember, they're not intelligent. They're not meant to work on intelligence at all. They are termed non-logical devices. Now let me highlight that one also. They are termed non-logical devices because they will boost all signals which have been detected. They're not selective. They don't know which signals should be sent and which signals should not be sent. And that is a limitation of a repeater. And another term that is repeating hubs, a combination of both repeaters and hubs that is going to make it a repeating hub. Bridge, let me show you the diagram. This is the bridge, and that is connecting one LAN with the other. So bridges are devices that connect one LAN to another LAN that uses the same protocol. Just be clear, bridges are there to just connect LAN with another LAN, but they are going to just to increase the LAN, maybe if there's one LAN and I want to have another LAN which is to be connected with the first one. So then I need I need the bridge to be there, and bridge is going to just simply get the signals from one LAN, will transmit to the second LAN, and it is not going to be the protocol translator. So the protocol that is used on both the LANs should be exactly same, not a different one. So you can see here, they are simply there to interconnect the LANs. And then we have the router, again, a very important topic for my examination point of view. What are routers doing? Routers' job is to enable the data packets to be routed between different networks, or they are there to join a LAN to a WAN. So again, let me highlight the key points here. They are there to join a LAN to a WAN. And second point is the routers are taking the data transmitted in one format. And now another point, let me highlight that one also. The routers are taking data transmitted in one packet in one format and is going to be converting it into another format or in another protocol so it can be understood by another network. Unlike bridges, bridges are working on similar protocols while routers can work on multiple protocols because they are doing the protocol translation also, thereby allowing the communication to take place over a larger area. And this is what is the summary. So here we can see restrict broadcasts to a LAN, act as a default gateway, can perform protocol translation, can move data between different networks, can calculate the best route to a network destination. So the first thing that we talked about, they are there to best find the best possible path to reach the destination. And this is a router. You can see my LAN is here. I want to connect to a LAN or a WAN, or I want to connect to the internet. The services of a router are going to be simply needed here. Broadband routers sit behind a firewall. The firewall protects the computer systems on a network. So main function of the router is to transmit internet and transmission protocols between two networks and allow private networks to be connected. So this is a brief discussion of the routers that you need to know. Prepare this topic very well for your papers. And then we have gateways, a network point or node that acts as an entrance to another network. So this is the definition of your gateway, that is acting as an entrance to another network. It is a key point for data on its way to or from other networks. It can be used to connect two or more dissimilar LANs which are using different networks. So here we can see they are there to connect dissimilar LANs. Similar LANs is your bridge, and dissimilar LANs is going to be your gateway. Gateway converts data packs from one protocol to another, and they are working as firewalls, servers, or as routers. In other words, any device that allows traffic to flow in and out of the network is treated as a gateway. Gateways can be wired or wireless. So this is again an important thing. And another device that is of importance is my modem. And modem, as the name implies, is modulator, demodulator. It is there to allow the analog data to be transmitted using the telephone line to another computer. So let me highlight. Modern computers work with digital data that we talk about, whereas the public telephone networks are using the analog data. So in order to make the transmission possible between the digital medium, which is my computer, and the analog medium, which is my telephone line, we need the services of a modem, that is modulator, demodulator. Just be very clear. They are simply there to translate the digital, and be very attentive. It's not like ADC. If you mention modem as ADC, then it will be considered as a wrong answer. It's conversion from digital to analog or vice versa, but it is using the telephone line. For example, if I am the computer, I'm the sender. My computer is generating the digital data. So on my end, it will be converting from digital to analog to be sent over the telephone wire. And then on the receiver's end, the computer is going to convert the data from analog to digital to be understood by that device. And that is why it is called the modulator demodulator. Modulator means, okay, now let me just, modulation or modulator is simply analog to digital to analog. And when it comes to demodulation, then it will be demodulation means it will be analog to digital. So the same device is performing both the function. That is why it is called the modulator, demodulator, or modem. In short, we call it modem. You can see here, MO is taken from the word modulator, and DEM is taken from the word demodulator, and the full word modem is being formed. So we do have wireless modems also. We do have modems in the form of they are present as a physical device that are present inside the computer as a card. They are present outside also as they are present in different forms just to make you. Now this is what the diagram is telling you. But this is what the whole process of modulation, demodulation is. Along with this, you need to know a little bit about the term software modem, that is basically soft modem, and that is using minimal hardware and using software in place of the hardware. Now, another one is the differences between routers and gateways. You can see here, routers are there to forward the data packets from one network to another, can route traffic from one network to another network, can be used to join LANs together to form a WAN. They can offer additional features such as dynamic routing, ability to forward the data by different routes. So this dynamic routing means the ability to forward the data by different routes. While gateways are converting one protocol to another protocol, similar thing. Can I convert data packets from one protocol to another and transfer data from one protocol to and translate data from one protocol to another? Do not support dynamic routing. So this is the end of today's class. I hope that you have understood each and everything. Jazakallah khair Kasira for being a part of the learning journey. Hope that inshallah in the next class we are going to just be there for another lesson. Till that time, take care of yourselves and your loved ones. May Allah bless you. May Allah help you. Allah Hafiz from my end.